Have you seen what happened in the recent weeks? Have you seen Peru, for example? The lands, the slides, all of the things that they are having. Some issues in Pakistan, China, any other place. Some places we have droughts. We don't have a lot of water. We have less water. So how do we plan for that? And how do we make sure that our cities will be ready for that? And that is the whole matter with the conversation. So my profession, before I became someone in public health, I used to be an engineer, an automotive engineer to be exact. And so what happened at the time is I was designing all of the systems to last for a long, long time. So we had to do a lot of risk assessment. Let me tell you about one of the systems that I designed so you'll see how extreme it is. Have any of you heard about the tire pressure monitoring system? Have you seen it? Well, that one, that's my baby, okay? And the tire pressure monitoring system is inside the tire. It's a sensor attached to the rim. It's going at an insane speed, just going and going in the whole thing. Temperature may go from minus 30 to 140 Celsius, the temperature of the rim right there. And it has to work, perform, and tell you pressure, temperature, acceleration, and other information. And it has a wireless battery inside. Well, I have to make that thing to last for 10 years. And that's how we got into risk management or risk assessment. So the reason why I ended up in sustainability was because I got promoted after so many systems that are still there. I got promoted and I became director of operations for a company. And so I was running manufacturing companies. And one time, the governments of California and Baja California and Mexico started to give fiscal incentives for sustainability. They say that if we had like sustainable processes and sustainable product design, then it will be tax deductible. So immediately overnight, I'd say that everything was going to be sustainable. I didn't know what it was, okay? So I got people from Boston to help me out, to figure out what sustainability was. And we ended up saving a lot of electricity, water, improving the yields for all of the raw materials that we have at my factory, and redesigning products to make them really sustainable. To make things short, what happened is that we ended up saving $68 million in 14 months. And since I didn't know what sustainability was, I knew how to do cost reductions, but not sustainability. And let me tell you something else. We reduced the environmental footprint for my products, all of the products for the factory, by about between 32 to 35%. Okay? So it was cheaper, it was better, and more sustainable. And I wanted to learn how to do that. So I came to Harvard to learn how to estimate health and environmental impacts, for sustainability. And I don't know how something led to another, and then I got a doctoral degree at the Harvard School of Public Health, and here I am. But I still have my engineering core, and I maintain it, and particularly in something important like climate change preparedness, it's really, really handy. So I think that you have seen this picture before. So this guy protected his home, protected his investment, even though everyone say that he was crazy, but his house was still there at the end of this, they call it a 500, it's extreme weather event. Well, it wasn't a 500-year event anymore because it happened every 25 years in this community. So this guy got ready and prepared. But in order to do that, you have to have a vision. What do you need to do in order to prepare for that? And that's precisely what the topic for this conversation would be today. So let's start. I'm not going to read the outline because we will go through all of these topics like climate change, mitigation and adaptation, and vulnerability assessment and resiliency and enhancement in a few moments. So I'm just going to go into climate change itself. This is the reason why we have these extreme weather events. So this is planet Earth, and we are orbiting a star that is wonderful, okay? It's giving us energy every single day. And you see that thin layer, that it seems like a haze surrounding the planet? That is the atmosphere. If you wanted to make a good analogy about the atmosphere, take an apple, peel it a little bit, and that peeling of the apple will be equivalent to Earth's atmosphere. That is the thickness of the atmosphere, okay? So that's where we live. That's where everything that we have seen that is alive lives, and we have to take care of that. But the important thing about it is that it is changing a little bit. This picture is actually from this year, from January 15th, and it shows how it has a dynamic change. Everything's changing in the atmosphere. And it seems like the problem is that we are causing a major shift in our atmospheric patterns. And regardless of what some people say, we are doing it. We are doing this. So how is that happening? This is the greenhouse effect. And this is what is keeping us alive here. Without the greenhouse gas effect, the medium temperature of planet Earth will be minus 12 Celsius, which is like what? Like 20 Fahrenheit, probably 10 Fahrenheit, I don't remember. Still, it will be frozen. It will be a snowball, okay? So the greenhouse gas effect by itself is not bad. The problem is that when you overdo it, then it's extremely bad. It's almost like if I give you a winter jacket in the summer and I say, wear it. You will still be alive, but you will not be comfortable, okay? And so that's what is happening with our planet, because we are increasing the concentration of greenhouse gases that are trapping heat, and that is affecting the weather patterns. And you'll see why in a few moments. So this is the natural way in which it's done. Out of 100% of solar energy that we get, we are supposed to reflect about 65% of it. 65% is a lot, okay? And then the rest of it should be kept here. Even a minor percentage, like 0.5 to 1%, the increase in heat capture on the planet is causing a lot of problems. So these are the greenhouse gas emissions that are causing that. We have carbon dioxide. It comes from combustion of anything, thermoelectric power plants, fuel for mobile emissions, meaning transportation, for any of the activities that we do. That nitrous oxide is actually from fertilizers most of the time. And we have methane. That comes from where? Where do you think that comes from? Methane. That's right, cows, cattle. And that's about 14% of all of the emissions, greenhouse gas emissions. And we are causing that, okay? And so some people say that we are not the ones that are doing this, that this is a natural thing. However, I would like you to see this inflection point right here. This is the beginning of the Industrial Revolution. That's at the end of the 18th century. And after that is like a hockey stick behavior for all of the greenhouse gases. They have been increasing and increasing. We actually reached the 400 ppm mark about 2 years ago. 400 parts per million of carbon dioxide. That it was unheard of since, 25 million years ago. So we are causing it. It's very likely that we are causing this, okay? And so the rate is increasing. Before, when they started to measure carbon dioxide, the rate was increasing, like 1 or 2 ppms every year or something. And then it started to increase and increase and increase. And now it's increasing even faster. And that's what we have right now. That's where we are right now. And can you tell me why you have like this up and down behavior for carbon dioxide? Anyone? Yes. That's right, seasonal. Why? Why do you think that happens? That's seasonal, but why? Winter, that's right. Winter in the northern hemisphere. So we have more biomass on the surface, okay, on the winter, on the northern hemisphere, and during the winter, um, a lot of that biomass dies, and so there is an increase in carbon dioxide. And then when that biomass, well, comes back to life in the spring and the summer, it takes carbon dioxide from the atmosphere and it goes down. However, the trend itself is going up. For the past at least century, has been going up and up. In 2016, and that is the most recent one, was the hottest year according to all scientists. However, I don't know if you can see the trend here, but well, it's very difficult right here. But out of the 10 hottest years that we have had, all of them have been in this century. All of them. The 21st century. We are in 2017. So, all of the 10 hottest years recorded in history, in the history of humankind, have been in this century. Okay? So, it seems like that is quite something. And this is a map of what may happen if we increase our average temperature by 3.3 degrees Celsius. And this is where we seem to be going right now with the current practices, with the current everything. So that means that is average. However, in the poles, I don't know, getting like, I don't know, really brownish, okay? That means that that's almost like 8 degrees Celsius. What would be 8 degrees Celsius, which is like what? Close to 12 Fahrenheit. So that is 12 degrees Fahrenheit hotter at the pole, the North Pole. What do you think will happen? The ice will melt, okay? And so that may actually endanger all the coastal cities in the United States and everywhere else. Okay, and so that's where we are heading right now. And why do we have that? Why do we have this extreme weather? Okay, the reason is because we are affecting the water cycle. Every time that we add heat to the atmosphere, so for every 1 degree centigrade increase in the average temperature of the atmosphere, we increase moisture retention capacity by 5%. Okay? That doesn't seem like a lot, but that means more clouds. And that means that some places that were kind of dry before, they will be like absolutely dry now, because that's where the atmosphere gets the moisture. And some places that were kind of wet before, now they will be super wet. You will have a lot of rain there. And that's why you have this bipolar behavior of the planet, where we have a lot of water in some places and not enough water in other places. And the reason is because the temperature of the atmosphere itself is increasing, and that's why we are having this bipolarity in the water patterns. And that's the reason why we have that. So anytime that somebody says, well, we had more snow last year. Well, the year before, 2015. Do you remember that? It was awful, wasn't it? Well, it was because of climate change. It was because of global warming. Regardless of what people say, it was because of that. We created a polar vortex that was generating an extreme event here on the northeastern part of the country. And that's why we had like 2.5 meters of snow. It was like up to here, remember? And then last year we didn't have a lot. And then this year we had almost nothing. We have like kind of, but not so much. So it's because of this erratic behavior that the natural ecosystems cannot cope. Do you remember when we had like 70 degrees in, when was it, January or February? Do you remember? It was great. However, the animals that were hibernating, they were waking up, they were hungry, their metabolisms were increasing up, They were extremely hungry, and they couldn't find anything to eat. And then we had some snow. They went back to sleep, but they didn't have the fat reserves that they used to have before. So a lot of the species in the natural ecosystem, they didn't make it because of this. And so that is one of the reasons of why we are having that. And remember when I told you that in some places we were taking moisture, and then other places were actually the recipients of moisture. So let me tell you, this is very evident right here. This is the area where the atmosphere takes the moisture from. So that will be where Egypt is, where Morocco. It will be the southern part of the United States, the northern part of Mexico. And so moisture goes up, and then it will be dumped in the northern part of Europe, the northern part of the United States, and southern Canada. That's where you will get the water. So that's why we have this erratic behavior. That's why we are having this, okay? And so I don't know what will happen if we keep increasing the temperature of the planet, because then we will have more moisture. That may mean very extreme storms. And so that is the situation. This is a map that was developed to illustrate what the situation would be with water, with precipitation. So all of the red areas and yellowish areas, that means that we will have less water than today, less precipitation, less rain than today. And all of the blue areas means that we will have more water than today. So as I told you before, the northern part of the United States, southern Canada will have more. All of Mexico and the southern part of the United States will have less, and so on. So what does that mean? If you are planning cities in these places, what would you do? For example, let's plan a suburb of Phoenix, Arizona. What should we do? What should we do? Maybe not doing it there? Well, guess what? We can. But let me tell you how. There are technologies right now that may enable you to save 90% of the water that you are using right now. You could recycle 100% of the water at this moment. We have the technologies to do so. How were they developed? They were developed by our dear friends from MIT here, Harvard, and other places, and they were developed for the US Navy. For them, it was important to recycle water, to do the desalinization the right way and the whole thing. So they did it. We have the technologies. It's only that we don't use them right now because we didn't need to use them before. Now we do. Now we do. But technically, if we are thinking about Phoenix, we should be thinking about the built environment that should be ready for no water and very extreme storms when they come. You will get all of your rain in 2 days. So how are you going to cope with that? And that's precisely what this map means, okay? What about southern Canada? Southern Canada, that means a lot of rain. That means, guess what? It will be a paradise by the end of the century. I'm not kidding about that. I'm buying land of my own, in southern Canada, northern Vermont. Why? Because I know that that place will be really good for humans. Really, really good for humans. So technically what you are supposed to do is to consider that when you are designing a city. Right now in Ottawa and Montreal and probably, many places in Canada, you have like tunnels to go around during the winter. Maybe you are not going to have that in the future. But you have to consider those things. And how do you plan for that? We will go through that process in a moment. But I wanted you to know that the only thing that will stay is weirdness. It will be weird. It will not be the same. Some people call it global weirdness instead of global warming because it is not the same as before. We are supposed to have a spring day, and a lot of people will say, well, this is normal for New England. I have been here for 12 years, and I do remember when we had a spring, Last year, we didn't have a spring. We went from winter, almost like winter, to summer suddenly, okay? That is not normal. That is not normal. Okay, well, this one is Hurricane Katrina, and it hit New Orleans in 2005. You know what happened there. You remember what happened there. And this is a Category 5 hurricane, which used to be rare. You used to have one of these every 10 or 20 years, but now we have Category 5 hurricanes every other year, okay, in the Gulf of Mexico and also in the Pacific side of it. And then there are some people that don't believe in climate change, but they are suffering more than anyone because of this. So some people in West Texas, they really can't do agriculture anymore. They are unable to do agriculture anymore. And something that we have done for them is to try to help them with these new technologies to save water, save at least 50% of the water, to save their activities. If they were planting cotton or they were planting something else, probably they should go into another crop that will be suitable for the new normal for them. But that's something that is happening. And okay, this picture is very revealing. This is the same picture, well, the same area. And there are 3 days, you know, of difference between both pictures. You can see the river. Well, the flooding was quite significant. And you can see the house that was saved right there. That's the one that I used for the cover of this presentation. But that didn't happen before. It is happening right now because of this extreme weather that we are getting out of climate change. And I believe you remember Sandy. This wasn't even a hurricane. They call it superstorm because of all the damages that it did to New York City. But it wasn't even a hurricane. And they didn't have something like this so severe since 1938. Okay, that was the last one. And well, you can see all the damage that it did even without being a hurricane, and how we were really like not planning for it. So whole areas in New Jersey and New York, particularly in Long Island, were flooded. 3 to 6 feet of water. Could you imagine all the losses, all the property that was completely destroyed because of this? And some people would like to build right there. I have a question for you. If you were an insurer, will you give them insurance to build there, to rebuild there? It's risky, isn't that right? And guess what? Some people would like to rebuild there because they own the land. So what can they do? I can tell you something that we recommended. The Dutch, okay? They have a lot of experience with dealing with water and floods and the whole thing. So what they did is the Dutch designed a house that actually floats. Every now and then they have floodings. And so they have like 4 pylons, okay? Imagine 4 pylons. And they have holes in the structure of the house. So, and it can float. And some people are doing that. Some people, what they opted to do was to give up the first floor of their house, of their homes, and they put everything on the second floor, and that's it. Yes, you have a question? Could you redesign?
In other words, you know, there's too many clouds in one place. I mean, this sounds utopian and scientific, but, you know, I guess you have to move clouds. Really move a cloud to areas that are arid. Have you ever heard of that?
Yes, actually,
And does that work?
the problem is that it will take a lot of energy. Let me tell you how it could be done conceptually, but it will take a lot of energy. So I'm taking this picture right here. If I wanted to move this hurricane away from New Orleans or something, I will have to have a satellite like right here, covering the sun. And then I will have to cover a very specific area to generate a low pressure point that will be a magnet for the hurricane. So we will be driving the hurricane away. However, the size of that satellite, the shadow of that, has to be literally the size of Texas. How do you make something like that? And so it is possible, not very likely with the level of technology that we have right now, but it is possible. Now, what about something else? About capturing carbon, for example. You see the Bahamas right here? This is actually coral, a coral reef and other things, okay? Well, what if, and this is something that we are working on right now, most of the interoceanic areas are like deserts, like the Sahara Desert. So any place between Chile and New Zealand and Australia, imagine that that is like a huge desert. Nothing lives there. Why? Because it is very iron deficient, so the organisms don't get anything, and there are not a lot of nutrients. Okay, some people are thinking about creating small robots that what they do is the following. They will take recycled iron from humans, particularly us. They will create like iron dust, okay? They will be spreading iron on the sea. And then they will be pumping the sediments from the bottom of the sea that are very rich in nutrients. And that way they will generate the specialized algae blooms in order to capture carbon. You could capture close to 500 million metric tons of carbon for every one of those events. So we can do geoengineering. We have the technical capability of that. Now, let me ask you a question. If we create several oases between Australia and Chile, are we going to affect the behavior of the animals in any way? You know, the whale sharks, they used to go to certain places to feed, and now they will know that there is an oasis somewhere and they will go and feed. Are we going to increase the population of whale sharks? Are we going to increase the population of big stingrays? Are we going to modify that? What will happen if humans disappear? Are they going to go back to normal? I don't know. That's why we are in a very weird situation now. And we may have to do that in order to survive. Well, you'll see why, because I think that I haven't gotten to sea level rise yet. So let me get there. This baby right here was Hurricane Patricia. This is the hurricane with the highest intensity ever recorded. 200 miles per hour with a wind gust of 235 miles per hour. So the category, the system that we have for hurricanes goes up to category 5. If this had been recorded in that system, there will be a new record and there will be a new category 6 or even category 7. And we just got this hurricane hitting Mexico. Did you hear about a lot of people dying in Mexico for this? I'm going to ask you like that real question. Anyone dying from Hurricane Patricia? It was like 2 years ago. Do you remember? No, me neither. But let me tell you why. Climate change preparedness. What you are going to see today, that's what we apply in that area. And that's why nobody died. But let me tell you something weird that happened after that. They had a tropical storm, which was like this, like very small compared to the big hurricane. And they weren't ready for that. They didn't respect the storm. So we have like 2 people dying of the tropical storm and no one dying and no property damages out of the biggest and meanest hurricane in history. And all of that because of climate change preparedness. So they had it, and then 2 weeks later, they dropped the guard and they had some problems. That's why we have to be ready all the time. The methodology that I'm about to show you is actually what they used in some of these areas. Well, something else that happened is happening all over the planet. So you heard about Peru like 2 or 3 weeks ago. Actually, there was one in Colombia like yesterday, probably, I don't remember. So there are a lot of damages caused by extreme weather, and they keep increasing. And glaciers are melting. Why is this important? Because you can see the damages that it did in Pakistan. It displaced 20 million people. But Glaciers are also responsible for providing a steady source of water for 2.5 billion people in this planet. About a third of the population gets water from glaciers in Asia. Okay? So, if for some reason all of the glaciers melt, right now they melt like really in a steady way, and so they become like streams that become rivers and the whole thing. What will happen if the glaciers completely melt? Floods, that's right. There will be floods for a few months and no water for the rest of the year. Okay? So either they are going to build huge dams in China, India, Pakistan, or other places, or they are going to have a lot of wars for water. So expect that one because that may be the next one. But still, it is because of climate change. And this picture is very revealing. So the red part means that water has melted, okay? And this is Greenland. Okay, so this is July 8th of 2012. This is July 12th of 2012. 4 years apart, 4 days apart. I wish it was years. 4 days apart. You can see how it went from some melting to all of this melting right there. And so part of the problem is that it is increasing the rate of degradation of the foundation of where the ice lies is actually being lubricated by water. And so ice is sliding a little bit faster to the Atlantic Ocean, and we don't know what is going to happen because of that. So this is how it looks like. It's a beautiful river. It's like the best water you could ever drink. It's right there. It's great. However, that only means that we are going to have a lot of melting for some time. And I want you to compare the ice cap in 1979 to 2009. And you can see the big difference. A lot of people actually claim that this is good for commerce. Why? Oh, easy. Okay? You could go from the port of, what do you want, Manchester or something. You could take this route, the polar route, and go directly to Shanghai without going all the way to the Suez Canal and then going the long way. So some people say, that is good for the UK, they say that. And then when I told them what will happen to the UK once that happened, once the ice cap was gone, they didn't like it that much. They will have only like a third of the land that they have right now. So it wasn't that cool to have commerce with China, you know? So the situation is actually increasing, and the thickness of the ice shelf is actually decreasing and decreasing. And some people that work in the Navy, the US Navy, they have information about the thickness of the ice in different places because submarines every now and then emerge in order to get air or for something else. And before, they could do it in very localized places. Now they tell me that they could do it almost anywhere because the thickness of the ice is very, very small. And in the Antarctic ice particularly, krill used to take cover on ice and feed on algae that was trapped on ice before, and that's how they survived the winter, okay? Now with no ice in the Antarctic Ocean, you may think that krill is great. No, it's being eaten by whales and the whole thing. Then what will happen is that they will starve to death because there will be not enough biomass of krill to reproduce. And so blue whales and other big animals are dying because of that. So, so what's in it for city planners? I have talked about all of this, but let me show you one country. This is Bangladesh right here. Okay? I want you to see this picture very closely. So this is what will happen to it. 1 meter of sea level rise, and it will displace 30 million people. About 20% of the land will be gone, and 30% of the crops will be gone. You want to see it again? Right there? Yes. Okay? Who is going to take those 30 million refugees? Well, probably India, but more likely India would be like, hey, Russia, United States, you were guilty of this. You take a few of them. And then they will be like, no, not me, because they are like whatever, whatever, whatever. And xenophobia will kick in. So the problem here is that the guys that are causing this may suffer, but they are not going to suffer as much as some of these poor countries, Bangladesh, the Maldives, for example. A lot of the Micronesia will disappear, the Pacific Micronesia. So that is the situation. Now, I hope that this presentation is available for everyone because I want you to play with these two sites right here to find out how sea level rise may affect your community. So let's check. So this is Boston. It's great, you know. People are buying land because in coastal areas because it's great. It increases the value of the property and everything. Excellent. Okay. Now let me tell you what is going to happen right now. Even if we stop carbon emissions at this moment, this is what is about to happen by the end of the century. A 1 meter sea level rise. Okay. So what happened here? All of these coastal areas were affected. Most of the coastal areas actually will be underwater, some of them. So some of the high value property will be down. So this is 7 meters. That is what will happen if we keep doing what we're doing right now in Greenland. The Greenland ice caps melt. Okay? So, my God, well, let's see. We will have a few islands here between Everett and Somerville. A few islands, okay? Right now, where we have most of Somerville will be underwater right now. So East Boston underwater. All of these places that were like high value properties. Chinatown actually will have a shoreline. Will be great. So Cambridge, you see this place? This is where we are right now. We may be underwater here because of this great river. And Harvard University will be down. So, and that is 7 meters. If we keep doing what we're doing, it's very likely that we will get there by the 22nd century. Now let's see the worst case scenario. The worst case scenario is not only that we keep doing what we're doing, but we do more. So let me see the island of Boston, which will be Beacon Hill, the Cambridge Common, a little bit of Chinatown, that's the island of Boston. All of these will be wiped out. This is where we are right now. We will be underwater. Brookline will be underwater. The island of Roxbury. So a lot of things will change. That is in 100 years. Less than 100 years. So how come I can walk downtown and see where the United States was born, where they did the tea ceremony, where they had the old customs house? It's still there. And it was there 200 and some years ago. And how come we are so reckless as to destroy everything just because we are denying the fact that we are causing climate change? So this may happen to Boston. Now let me show you another example for people that love Washington and they don't make legislation to stop the whole thing. Okay, so this is 1 meter. Okay, this is 7 meters. And this is if the worst happens. You see, this whole peninsula will disappear. Okay, so a lot of Maryland and Delaware will be out. Actually, most of Delaware will disappear. Okay, and Washington, D.C. will be underwater by the end of this century. You may say, well, nothing will happen. We will build dikes here and everything will be fine. Yes, sure. People with money will do that. What about people with no money? So that is the situation. And I wanted to show you what will happen with 6 meters of sea level rise, which is likely to happen if we keep continue doing what we're doing right now at the same rate, the whole thing. Okay? So Miami Beach, Fort Lauderdale will be gone completely. Most of the coast of the eastern coast of Florida will be gone. Most of the western coast of Florida, the Gulf of Mexico will be gone. Unfortunately, well, other places will be gone as well. New Orleans, gone. Absolutely gone. Carlos, you're from Merida. Merida will become a seaport now. Now it's like 25 miles away from the sea, but it will become a seaport. That may be good for the economy, my friend. We should invest in real estate. They don't listen anyhow, so, well, this is how our planet looks like right now. This is how our planet will look like if all of the ice caps melt. Check this. Okay, check Brazil and check Australia if you want to. This will be an inner sea in Australia, will be like super great. Most of Micronesia will disappear. Indonesia will disappear. This is even called the Sea of Azov. It even has a name now. Okay, the Sea of Azov. See the Amazonian Gulf, I think that they will call this thing. Yucatan Peninsula will be gone, so no real estate anymore over there. So the Baja California Peninsula almost gone. In Argentina, mostly gone. So, want to see it again? This is what may happen. So either we are going to start planning cities to be absolutely waterproof, that they float, or we stop the whole thing. Okay? I know that it's actually your job to start the work. We have started signaling the alarm. A lot of people believe in what we say. A lot of people don't believe in what we say. However, everything that I have shown here is science-based. Okay? So, this will be the new United States of the 22nd century if all of the ice caps melt. So, surprisingly, most of the people that don't believe in climate change will lose everything. Like for real. Louisiana, Mississippi, Alabama, Georgia, South Carolina, North Carolina. So, yeah, half of Massachusetts will be gone. It will be the Massachusetts Peninsula now. So this is where we are going right now. We may be able to stop it if we start at this moment, but we don't know. So that leads me to this. Anytime that you design a city, we should be thinking about two things: carbon mitigation and carbon adaptation. Carbon mitigation means to stop emitting carbon to the atmosphere. Anything that prevents carbon from reaching the atmosphere is carbon mitigation. Using hybrid vehicles, using solar panels, going to renewable energies, energy efficiency, all of those things are carbon mitigation interventions. And carbon adaptation refers to any activity to cope with climate change. We know that it's going to happen. So how do we cope with that? One example that I have is how to save the island of Manhattan. So they are thinking about 3 dikes, one here, and one here. And with that, they could take up to 6 meters of sea level rise. So have you seen these science fiction movies and everything where they have like these huge dikes surrounding New York City? Well, they aren't true, because what they are going to do is they are going to build the dikes somewhere else. And these are the 3 points: near Staten Island, and over here on, is it called Jamaica Bay? No, this is Jamaica Bay. I don't remember this one, but this is Long Island. Anyhow, they are going to build it right here. And so that will be infrastructure that is going to be built in order to protect New York City and most of the metropolitan area of, surrounding New York City. Long Island and most of it, like this Jamaica Bay and other places, will be gone. So that is climate change adaptation. And there is a trend. Most of the time, Climate change mitigation refers to energy, photovoltaic energy, energy efficiency, driving hybrid vehicles, electric vehicles, switching to natural gas, the whole thing. And most of the adaptation things refer to water and health. How do we prepare or make sure that hospitals are ready for climate change? Building dikes, building infrastructure to take the water. How do we drain the things really fast because we will have like flash floodings? How do we do that? That is climate change adaptation. So this is what I just say, I think, right there. So climate change mitigation is related to energy. Climate change adaptation is related mostly to water and health. And this is important to note for any city planners. Think about this whenever you are planning a city. And now I will go to climate change preparedness. Okay, and I have several examples. So these are examples of climate change adaptations when they are lining up canals, irrigation canals, when they build new dams, but they let salmon, to go upstream and the whole thing. When you do hydroponic farms, well, now I'm going to talk about two concepts. The first one is vulnerability. Vulnerability, so in this case, climate change vulnerability, means the degree in which climate change events affect you, affect your health, affect your housing, affect your infrastructure, your food supply, your transportation systems, your energy generation, and your quality of life as a whole. President Obama, when he took office, and there was a snowstorm in Washington, he couldn't believe that Washington will be completely paralyzed by 3 or 4 inches of snow, when in Chicago, according to him, everyone was working perfectly with 3 or 4 inches of snow, and schools were working and businesses were working and the whole thing. Why? Because Chicago is less vulnerable to snowstorms than Washington. Washington wasn't ready. Okay? So that's an example of that. And what I have, the picture that I have here, it's about a highway that is going from the US border with San Diego to the city of Ensenada, Mexico. Okay? This is how the highway used to look like. This is what happened after a big storm. This is not a toy truck. This is a real truck. Okay? This is what happened. So they were very vulnerable. However, the cool thing about that is that they were also resilient, and I'll tell you the story in a moment. Resiliency is the ability to bounce back from any of these extreme weather events. Okay? I was using the extreme case of the house that floats, so it doesn't matter what happens, if sea level rise occurs or something, it doesn't matter. The house would be there. Okay? So this is like a super resilient system. You may have a flash flooding, but once the level of the water goes down, the house will go down, will go to its foundation, and it will be fine. Okay? So this is an extreme view of resiliency. Another one will be, you have a flash flooding. What if you have like porous concrete and it could take all of the rain? Then you could take it. You could be less vulnerable and more resilient at the same time. So that's what you're doing. Bouncing back from any of these extreme weather events, that's what you will have there. And so when you do a vulnerability assessment and you increase your resiliency, then you have climate change preparedness. That's where we want to go. And that brings me to this road, okay? We did an assessment of climate change vulnerability for the city of Ensenada, and we saw that there was only one highway going north to the city of Tijuana and San Diego. And if something happened there, they will be in deep trouble. So the recommendation was to work on the secondary road, which was in a very bad shape, but still salvageable. And what we did is try to make it better, just in case. So you saw what happened to the highway, okay? But in reality, the only thing that it did, it created some minor delays in traffic just for going the other way to the other two-lane highway, which was in perfect working order, and you will use it just to get by that particular spot where you have the problem in the highway. And it was completely okay. So this is an example of how you can plan infrastructure thinking about what if. What if I have this? What if I have like a big storm, a landslide? What if I have a snowstorm where I didn't have it before? What if I have no water in the future? What if, what if, what if? And that's what you do in order to get there. And so the most interested party in part of my research are insurance companies. And the reason is because they would like to determine if they are going to give insurance or issue insurance to people that are in very high risk areas. And that's why they actually are considering all this science of climate change preparedness as a fundamental part of their business proposition, their business models, because if not, they will have to pay a lot. When Superstorm Sandy happened, the insurance industry lost a lot of money. And the reason was because they were insuring a lot of people that were in very high risky areas. But in very risky areas, and they decided not to insure them anymore. People went to the government. The government said, yeah, we'll give you flood insurance. And then they got hammered 2 years later. And the government decided, I'm not sure if I'm going to give you insurance or I'm going to help you out to be better. And that's why a lot of people decided to abandon the first floor and decided to build on the second floor and up. And that's what they did in those communities, okay? And that's how technologies like the Touch House that I show you came to town. And that's how they have now new technologies to be absolutely resilient in case there is a flooding or a flash flood, okay? So the most important challenges for climate change preparedness are the following. First, it's very difficult to know where it hurts. Absolutely difficult to know where it hurts. Let me give you one example. If I-90 is suddenly closed from here to Worcester, what do we do? Has anyone thought about it? Is there a big risk about this particular road? So what do we do? And when I ask this question, even to people that are city planners, they have no answer sometimes. They think that, oh, well, maybe we can use 93 to 95 and then go all the way to, I don't know, Gardner or whatever, and then go around. Sure. That's a big detour in order to go from here to Worcester, Massachusetts. So we don't know where it hurts. Okay, let me give you another one. What will happen if the Park Street T station is flooded? That's where the red line is, all of the green lines pass through that, and the whole thing. If the Park Street T station is flooded, what will happen? Do we have a plan for that? And then you start checking that actually we never thought about it. We never thought about it. And some of the solutions are not very hard to implement. It's only that we never thought about it. And if for some reason we have to execute really fast, it will cost a lot of money. If instead we start investing in some infrastructure for getting ready for climate change little by little, in 40 years, we will be absolutely ready for the end of the century without investing a lot of money. The problem is, if we don't know where it hurts, we don't know where to invest, and we don't know how to invest, and we don't know what the possibilities could be. So that is the first problem with climate change preparedness. It is very difficult to plan for the unexpected. That's the second thing. Most communities are really skeptical about climate change and its potential consequences, even here. You know, The People's Republic of Cambridge is right there. And even them, when we did the climate change preparedness plan for them, they were highly skeptical about some of the things that were about to happen, and they did happen afterwards. And guess what? They were ready because people like all of us in the academic community were pushing for that. That's why they were ready, okay? And most communities are afraid of the cost of changing infrastructure. However, if they do it little by little, they will not feel it, okay? And that is the whole thing. That's why you are here. That's why you have to think about this. And that's why we are going to go through the process of doing climate change preparedness process. You'll see why. Well, how do we do it? In order to evaluate vulnerability and resiliency, I would like to show you one of the ways in which it's done. It's not the only way by any means, but it is one of the ways in which it's done. We are using the same methodology that NASA, the US military, and aerospace companies are using to evaluate risk, okay? And that is called failure mode and effects analysis. And so what it does is that it creates scenarios. Like, for example, I told you, what will happen if the Park Street T station is flooded? And you will be like, why did that happen? I don't know. It just happened. So what would you do? And then you are thinking about the whole thing. Is that going to shut down the trains, for example? Red line, very likely. Green line, very likely. So what are we going to do about it, okay? And so you start developing for resiliency completely. Like, for example, the third rail that you can see that is almost at the floor level right there, probably shouldn't be there. Probably should be right there in the roof. And then it will be completely resilient. Well, it will have very low vulnerability to floodings right there in the Park Street station because the energy will come from the top, okay? So this is something as simple as doing that. However, if we don't plan it and we need to do it in 1 year, we will spend billions of dollars. If we do it in 40 years, we will be spending $12 million this year, $12 million next year, and so on until we are absolutely ready, okay? So you have to create scenarios. What about the MGH? What if it's flooded? We did a very small assessment for them, for partners in health, just to show them the vulnerabilities that they have. If some of the hospitals are flooded, where do you think the backup generator is? It's in the basement, that's right. The switchboard, the electric switchboard, in the basement. Therefore, they will be flooded. If I'm a patient in critical care, which I may be, because at that time I will be like 70 something, 80, and I may be in critical care in the MGH in the future, to die just because somebody didn't plan for that. What are the quick solutions for that? You change the switchboard to the second or third floor. Just change the backup generator to another place. And then with that, you will be ready. So if power fails in the city because of a huge storm in the year 2080, they will have the backup generators working. They will have everything, the switchboards, and the critical care patients will be comfortable and nobody will have to be evacuated. You see how it works? But in order to do that, we need to create some scenarios. Well, the US military created this methodology in 1949. So it has been around for 65 years. 65 years. And it's the military standard 1629A. Then some people from the military went to NASA to work for NASA, and they started to do it in NASA and apply it to the Apollo missions after Apollo 1. Do you remember what happened in Apollo 1? Should I say? Well, the astronauts in Apollo 1 were testing all of the systems before going into space. That was Gus Grissom right there. And they were testing everything. They were working on a pure oxygen atmosphere. They had one short circuit, and that was the end of them, because in a pure oxygen atmosphere, everything just went into flames and it killed the astronauts completely. After that, they decided to do this risk assessment methodology, and they did it for Apollo, and they did it for the beginning of the space shuttle until they stopped doing that in 1983. And you saw what happened in 1986. Okay? So, well, in any case, the first civilian failure mode and effects analysis was performed by the Ford Motor Company in the 1970s after the Pinto fiasco. Do you remember the Ford Pinto? What was that? What was that? What was the Ford Pinto? It was a car and a truck, wasn't it?
No, it's a car.
Yeah. Yeah, the Pinto. That's right, a flat back. That's right. It was very dangerous because it got hit by close to the fuel tank. It will completely explode. Okay, and that's why they decided to do something in order to change that, and they decided to use this methodology. Well, then after that, it was used by corporations, and after the Challenger accident, NASA decided to go back to that. And it became the standard procedure for risk assessment in industry. And now this brings me to this. You got these pages right here? Okay. Yeah. I believe that you have the occurrence and severity ones. Maybe not the detection ones, but it doesn't matter because that's like the easiest one. And so essentially what we do with this is the following. We create one scenario, okay? And we say what the failure modes will be after that scenario, okay? The Park Street T station is flooded. That is a fact. It's a scenario. You don't have to question how it happened. It's happening, okay? So what is the failure mode right there? Trains do not work. Which ones? The red line is not working. The red line is not working. Why not? Well, and then you check, well, the third rail right there is floated, and because of that, there is a short circuit in the whole thing. Maybe the green line is working because it's above the red line, but I don't know. Right now, I'm going to limit myself to the red line. And so, right here, I have a table of occurrence. It's like the likelihood that it may happen, okay? And right now, at this moment, we truly don't know if it will happen or not. Nobody has done a study of the likelihood of having a flooded T station at Park Street. No one. So if I were using my own tables, okay, it's the probability is high with no information. Failure is almost inevitable. Maybe not that high. What about the second one, number 9? High with limited information? No, it's not high. High with objective information, failure mode is almost inevitable in the whole thing. Nope, it's not that. Moderate with no information? Not likely. What about low with no information? That will be a 3. It's a low possibility because it hasn't happened before. Okay? It's not likely to happen because we have a dam, we have a lot of things. However, we don't know anything. We have no information about that. So the occurrence of that, until we get a study to find out the likelihood of having a flooding in Park Street, will be a 3 right there. This is how you use the table. Now, let's see the occurrence of a failure or a problem. I'm driving blindfolded in Kenmore Square. What is the likelihood that I will have an accident? Very high, isn't it? Very high. I have no information, by the way. So it's high with no information, and failure is almost inevitable. Yep, that's the one. I'm driving blindfolded in Kenmore Square. That may be a 10. You see how it works? Okay. So it depends on how we create the scenarios. Like, for example, do you remember when the water main broke like 8 years ago here? Most people don't, but what happened is that for 3 days we have like no drinking water in Boston. So what happened there? It was actually something very unlikely, and but now we have the anecdote that it may happen. So, for example, in this case, the occurrence may be moderate, but we have anecdotal information that it may happen again or something like that. So that may be a 6. You see, you have to think in those terms. And as with anything else, is practice, practice, practice. You have to practice until you get to there. Okay, so the occurrence is the likelihood of an event. And you get a number from 1 to 10 right there. The likelihood that Park Street will be flooded. The likelihood that I may have an accident if I'm driving blindfolded in Kenmore Square. The likelihood that the MGH may be flooded in 100 years because of an extreme weather event and the Charles River Dam is toppled. I don't know. You have to work with this, okay? Then the other number is severity. Okay, severity, for example, will give you like what are the effects of that? One example that I have is a number 10. Failure occurs without warning and it endangers human life completely. Let me tell you what will be a 10. An asteroid is coming towards us from the sun. We will not be able to see it, okay? Not be able to see it. It will come without warning and it will kill people. That's a 10, for example. What if we have like the asteroid detection system somewhere in the moon or some satellites, and they tell us an asteroid is coming to Earth, it's coming through the sun, it's very likely to kill people. You have 3 minutes to take cover. That's a 9. Now you can see it, okay? And so severity could be something as it destroys a system. Like when we had the water main breaking here in Boston, we didn't have drinking water for 3 days. It wasn't that bad, except that, you know, the Star Market that is in any place around here, there were panic riots over there. People were getting water and fighting for water and the whole thing. It was a problem. Nobody died. There were a few people that were bruised and with black eyes or something, but that's it. Nothing else happened. So that may be like a 5 or a 6, I don't know. Well, no, it's not a minor thing. So it will be, let me see, a 7. Noticeable disruption of the natural ecosystems or human health. It is a major inconvenience for the community and it hinders the way the city works. That may be a 7. But as always, you have to read it and you have to practice for that. Then another one that you may not have, so I'm going to read it, but this is like the easiest one, detection. Detection is like, I don't think that you have it, but if you do, that's great. But if you don't, this is like the easiest one. Almost impossible to detect is a 10. What is that? I have no detection means for that. Imagine that I have no water sensors for seawater levels anywhere. So I don't know where sea level rise is happening or not. I'm not measuring that. I have no sensors. I'm not even looking at that. I'm just blind and just waiting for water to come and rise. Something like that. That's a 10. You have no detection system. What about a 9 will be if you have some controls or no controls, sorry, but still you have some ways to see it. It's almost like, would you able to, like for example, are you going to be able to detect if the water main breaks in Massachusetts? Any sensors, if it's underground, if it doesn't make a sound, anything? Yeah, it depends on the type of leak, and it depends on the pressure of the water, and it depends on many things. However, what if, for example, and let me bring it down to something manageable. I have a sensor for pressure on the water system in Boston, and every time that I have a drop in pressure between 2 points in a pipe, I know that there is a leak right there. I'm detecting that almost immediately, and I'm detecting that all the time, meaning that that will be a 1 or a 2 in detection. That I have a very specific detection system for that thing. A 6 will be a double inspection. You know how inspectors go and they see the pipes and they are like, yes, oh, I really love the picture and the whole thing, and looking at the whole thing, and they may be like laughing at a joke and they miss one. They miss just one leak right there. That may be bad, but that's a 6. That means that it's a visual inspection. It's a human, okay? Well, in any case, why do we have these numbers? I teach people how to use these numbers because what we will do after that is that we will multiply the 3 numbers and then get a risk priority number. So the number in a scale 1 to 10 for occurrence, the number in a scale 1 to 10 for severity, and the number in a scale 1 to 10 for detection. For that particular failure mode, for that particular place or piece of infrastructure, we are determining how bad it is. One example, again, Park Street is flooded, okay? So I believe that the severity was like a 6 or a 7. The city doesn't work, so it's a 7. Let's say that it's a 7. Severity, not killing anyone, so let me see. Severity may be right now, let me see. It's not killing anyone, but it's very noticeable disruption in the ecosystem, in infrastructure. So that may be a 6. In severity, it's a 6. In occurrence, 6 or 7, okay, will be in severity. On occurrence, well, we have no information, but remember that we have no information, but it's very unlikely to happen because it has never happened before, and we have a lot of systems. So let's say that is a 3. 3 times 7, that's 21. And detection systems, we have no detection systems for that at all. That may be, I don't know, let's say a 10 right now. We have no way to detect it. So 21 times 10, that will be 210. And that will be the risk priority number. Okay? And so every time that we get a number that is a 9 or a 10 in any of the 3 factors, you have to do something. You have to do a corrective action in order to reduce the risk. Or you take any you do a corrective action for anything with a risk priority number of 150 or higher. So in this case, for Park Street, we got 210. We have to drop that risk. We have to reduce that risk. How do we do it? Well, we have no study showing the likelihood that we may be flooded in Park Street. So what should we do? Study the likelihood that we will be flooded in Park Street. Okay? Or we could reduce the severity or the likelihood that it will be shut down. How do we reduce the occurrence, the likelihood? Instead of having the third rail right next to the floor, we will put it like on the top. And that way, the likelihood will be drastically reduced. Even if it's flooded like 3 feet, maybe the T will be working. Maybe it will be going at a very low speed, but it will be working. And service will be there because the third rail, it's right there on the roof. So that's what you need to do. That's what you need to do. Either you reduce the likelihood for it to happen. You reduce the severity. What if we had another thing, like for example, if the T is not working here in Boston, we have like a specialized procedure of buses, and we are closing some of the streets that will only take public transportation. And that will be like a surrogate T that is working. Yes?
One of the interesting pieces of argument from a public agency standpoint, it helps them prioritize, if you're the T, now you know you're going to pay attention to the Park Street, maybe it's installing pumps.
That's right.
After Sandy, there was a lot of talk, there's still a lot of talk in New York about sort of the triage plan. Which stations do we have to focus on? What is it to do? But without a system like this, you're overwhelmed.
That's right.
You're just going to throw up your hands and say, we have no idea what to do. We have no idea how to do a cost estimate. We have no idea how to plan an investment plan or a plan of attack. With this way, now if you go through the whole system, you do it. And you can say, okay, Park Street, you have to worry about which year maybe not.
That's absolutely right. And the important thing is this. It's not only transportation. You are considering food production and food distribution systems. You are considering energy generation. You are considering healthcare and hospitals. You are considering other things. And that's precisely what you do with this. So that is the importance of this. So let me tell you how this is applied. I teach people how to assess risk. I call it climate change vulnerability assessment methodology. And I teach like 300 people in a city how to do it. All the city planners, all the people that are building infrastructure, people in the community that are just living there, could be medical doctors, engineers, housewives, could be anyone in the community, absolutely anyone in the community. They know how to do it, and they work together in creating these climate change preparedness plans. If you do it with 300 people, let's say that 50 will tackle transportation, 50 will tackle telecommunications, 50 will tackle the healthcare system, 50 will tackle, and so on. At the end, they convey and they prepare the climate change preparedness plan, and they reduce vulnerability for the city, and they increase resiliency in a very significant way, because people that live in the community did it. I didn't hire a consultant. I didn't hire anyone else to come and do it, and then it will be a black box, and it will tell you what the actions will be. Let me tell you one example that is very clear. With Hurricane Patricia, okay? One of the actions was go and sweep your streets and make sure that there is no trash anywhere in your community. Why? Because trash will go into the sewers and they will block the sewers, and then you will have a flooding. So everyone in the community, since they knew what to do when the storm was coming, they started to sweep everything, make sure that it was completely clean. So when the hurricane came, the sewers were completely and absolutely clean. In the meantime, city planners knew that they had to do an inspection, particularly in some of the most important joints of the system for sewers, like in order to make sure that there were no major well, they call them grease, whatever. I don't want to know what they are, but they claim that is like a grease ball that generates right there at the wrong place, and it will clog the whole system. Well, they were taking care of them, getting them out. They were making sure, for example, as well, that all of the for example, water mains and everything will be closed, at least for during the storm, and people will take water, they will take precautions, and they did it in order to make sure that the pressure, if for some reason there was a damage, the pressure will cause more damage. So at the end, it was like a very controlled thing, and they were just getting ready, and then the hurricane came, 200 and something miles an hour, and nothing happened. After that, they went out, cleaned up the whole thing, and it was ready. The problem is that they get complacent, and that's why two weeks later, they got hit by a very minor thing. Because they thought, oh, we survived Patricia, so this is nothing. Yeah, right. That's what happens. You can never drop the guard. However, this is what you do. This is essentially what you do. And so there is a table which probably I'm going to share with you guys, but it's not a big deal. You could do it in an Excel spreadsheet whenever you want. So essentially it tells you what is the process that you are analyzing. For example, transportation. I'm making this up. I don't know. Transportation. That is the operation I'm analyzing. What is the failure mode? Trains are not working. The red line in this case, not working. What is the cause of failure? Flooding at the Park Street T station. So it's right there. And then you assess the severity, occurrence, and detection levels for that. You get their RPN, which in our case was like 210. And then you decide, am I going to do something? Yes or no? And then you are going to assign someone a very specific task in order to reduce the risk of that. And that's what you do. And you keep doing that hundreds of times until you reduce the whole vulnerability for your city. The secret here is no single city planner can do it. You have to train the whole community to do it, because then it will be very accurate, because people in the community will know how to do it. It will be very democratic. If we found out that the biggest risk is something in transportation, for example, anyone in healthcare will support that because they know the process. Anyone in telecommunications, for example, they will support this investment to reduce our vulnerability because they understand the process. And the other thing is having an army doing this is really neat because then you can do it every year. Every single year. It's not like it's George's job to do this thing. No, it's the community's job to do it, and they know how that they need to do it, and they get ready and they do it every single year. And that's how we do it. And so at the end, we get the risk priority numbers, okay? For example, the highest risk will be first, and we know what is the highest risk for the community, and then the second highest, the third highest, and so on, until you actually know what are your most important risks, and then you deal with them. Once you deal with them, then you go to the next priority, and you keep doing that, okay? And you do this at every stage and for every single transportation, well, for every single category. I hope that I have the categories because I don't remember, but I hope that I do. But you have to consider very stressful situations, like what is the likelihood of having a big storm? What is the likelihood that we will have a snowstorm in Atlanta, Georgia, for example? We didn't before, now we do. And you saw what happened. The whole highway was closed, shut down for 3 days. People were there in their cars for 2 days. Okay, so you have to consider those things. And you have to identify key transportation, energy, housing, food distribution, and communications infrastructure in order to do the process. Usually this is what I recommend. I recommend these 9 sectors. So out of 300 people in the community, I assign 30 or 40 or 50 to each one of these sectors, depending on the size of the sector. For example, it will be health and healthcare infrastructure, meaning hospitals, meaning, for example, well, the ambulances, where are they? Fire truck and the whole thing. So I have to check those things. I have to check food production and food distribution systems. Like, for example, we don't produce a lot of food here, but where does it come from? How do we get it here? What if one of the roads is closed? Can we use rail, the rail in order to bring food to Boston? Can we use the airport? I don't know, but we have to find out all of those things. Water management and distribution. Then housing and urban public spaces. So, for example, what if we have a heat wave? When are we going to have a 100-degree temperature in Boston in the next 10 years? What do you think? Very likely, isn't it? Are we going to have 5 to 10 days of 100 degrees in Boston in the next 10 years? Likely. So we have to get ready for that. How are we going to plan public spaces? Are we going to post like canvases or shades or something in very dedicated places in the city in order to make sure that people will be comfortable? Are we going to, for example, make sure that every senior citizen has access to air conditioning in order to make sure that they will not have kidney failure and then, God forbid, no dialysis or something and they may die? So we have to be ready for that. Yes? Absolutely, absolutely. And it could be, yeah, but in that case, what if, for example, there is a technology that is heat absorption refrigeration, okay? If I have a solar concentrator for some large buildings, it could be done. I have a solar concentrator, and then what I can do is simply use what is called the Einstein refrigeration system. Yeah, invented by Albert Einstein, by the way. And then I can use that in order to provide refrigeration without electricity to some of the buildings, like large auditoriums, like large buildings. Then I can put people there without using a lot of electricity. But we have to plan for that. okay? What about, for example, insulation? You use it for energy efficiency, but it may save lives in those heat waves because temperature will not rise as high, as it would without insulation. So, but you have to plan for that. And you're absolutely right. You have to think about multi-system approaches in order to make sure that you will be ready for that. Absolutely. Okay. So those are the 9 things, and usually I assign a few dozen people to each one of them, and they come back to me, and then we create a climate change preparedness plan based on that. Next year, we are going to analyze the possibility of moving the third rail of the red line on the Park Street T station to the roof. What will be the cost? Can we do it in a very cost-effective way? Can we do it during the weekends when they shut down the T from 2 a.m. to 6 a.m. on Saturdays and Sundays or whatever? Can we move part of it? Can we do this? Can we do that? And then you go on until you actually do it, okay? And so once you identify specific cases, you have to check what are the potential hotspots in order to apply this. That's why I have been talking about the Park Street T station, South Station, the train station, the bus station, the airport itself, things like that, hotspots. You have to think about those things, okay? Then once you consider extreme situations, and then you do your climate change preparedness plans by doing scenarios, then you can prepare documents that will be used by city planners in order to plan for any capital expenditures for the future. Even if they are minor, they have to be there. And the cool thing about this is that the community will be on this because the whole community participated on doing a climate change preparedness plan. And I had one example. We may not have a lot of time because I can see the time right now. So since you know how it's being used, how we use the tables, we may not go into the mini workshop, but I'm just going to go into this example. So this is a 1 meter sea level rise in the future by the end of the century, okay? And the Charles River Dam during a storm is actually overwhelmed. And the MGH is like right here next to the Charles River Dam. And the MGH is flooded. So what will happen? One example. In this case, well, identifying which are the likely places to analyze. I have the Massachusetts General Hospital and the Mount Auburn Hospital. They may be affected. So I'm analyzing those two. And in the case of Mass General, 1 meter sea level rise, or in this case, brine, in the year 2090. What are the consequences? So let's find out. The process is critical care for patients. The failure mode is there is no electricity for critical care. Okay? The potential cause of failure, inappropriate water protection for electrical switchboard. What does it mean? My switchboard was in the basement, it's flooded, therefore it's completely useless. That's what happened in the Daiichi plant in Japan, by the way. Everything was at either ground level or in a basement level. And that's why everything was fried by the tsunami. And that's the whole thing. That's the end of it. Well, in any case, the severity of it is a 9. It will kill people with a warning. You know, machines will go down and everyone will be like, I don't know what to do, but you know that they are about to die. Occurrence, it's a 4. Why is it a 4? Well, if we go to the occurrence table, probability, it's moderate likelihood. Okay, in this case, sorry, I'm on the wrong one, right here. A 4 will be moderate with solid and objective information. Failure occurrence for our process infrastructure or environmental problem has been fully characterized. It occurs in a moderate to high basis based on recorded information. By that time, believe me, they will have the information about that, okay? So it's a 4, and the detection is a 3, okay? Detection levels is a 3. Why? They have sensors, they know that it's about to happen, they have the weather reports, whatever. So at the end, you multiply these three and you get a risk priority number of 108. However, since you got a severity of 9, you have to do something about this one. So what do we do? What about doing a waterproof electrical system? Even it works underwater. That is a solution, not even moving the switchboard. It's only a waterproof switch. And then with that, you reduce the occurrence in a very significant way, and the new RPN will be 54. So you reduce your risk by half just by having waterproof switchboards right there. What about this one? So it's the same process, critical care, no electricity, and the potential cause of failure is that we don't have the electrical switchboard in the right place. The severity, oh no, this was another solution in this case. It's a solar backup systems for air conditioning and electricity. So the severity or the occurrence of this will go down, and the severity will not be as high. So the RPM will be 24. So another one that would be on this case, for example, if we have something with a severity of 9, which would be there is no mobility, there is no way to evacuate patients from the hospital. That is the problem, okay? So if it's flooded, the MGH is flooded, you cannot get there. It's completely surrounded by water. How would you get there? Boat. We already have them. How are they called? Do we use them for? That's right, the dock boats. If we reassign the dock boats in order to evacuate everyone from hospitals in case they are flooded, then they will become ambulances, but we will have them ready. And so no matter what the operators say, the moment we have the flooding, they become ambulances according to the city, and they have to help, okay? See how it works? It's just like that. And we reduce the risk priority number from 243 to 54. Yes?
I really love this new system. I have a question. So, for example, if an occurrence of critical illness that caused sleep flooding, the occurrence is like maybe 1 or 2 during
Yes.
often, and then the severity is like a 9 or 10. To create the capability for the cost is tremendous cost.
But that will be.
So I guess what I'm trying to say is that something where the occurrence may not be as frequent, would the city want to spend? Because that may be a some part, because you never know if it's going to happen.
But guess what? That's why we will have to have a symposium within the city to say, are we going to reassign the dock boats to evacuate everyone from the hospital? We have money for that. Or are we going to build the third rail at the top of the, on the roof of the Park Street? Now I think that we have to evacuate people. Most likely it will be like that. So it will be the community defining what the next actions will be. And maybe not this year, but next year, we will be considering how to put the tier rail on the top. Then the year after, we will do like a pilot to check if it works. Then the year after, we will do just a few 100 yards just to find out. And then on year 10, it will be done, and people will not notice that. That's it. That's how you do it. It's change by evolution, not revolution. Okay? And so, now, I'm going to talk about your work. What do you think are the most vulnerable areas, or areas of opportunity that you could solve by using this exercise? Like, think about your communities. Where could you use it? Where could you use it? Transit, that's one. Transit. So, go ahead. I agree. Agriculture, in some agricultural communities, it will be agriculture. Schools, yeah, like schools and hospitals. Like, for example, what if we have, in this case, an amphibian vehicle in every hospital from now on. Whatever happens, we may need it, okay? Or schools. What if we have this porous cement in every school, porous concrete, so it will never be flooded? And every basketball court in the city actually will take snow and will take other stuff, and it will percolate during the winter. And that's the place where we are going to store snow. I don't know, but that's precisely what we are trying to do, trying to find out how can we identify not only vulnerabilities but opportunities with this thing. So do you think that you will be able to implement this in your community? I think so. And the only thing is, you only saw like an hour and a half of this. Technically, it's a workshop that takes a whole day to train a community. It's like 300 people, but it's like a party, okay? You buy food, you tell them about everything, they tell you about the problems. The poor mayor gets like hammered that day, but it doesn't matter because after that, he will be fine or she will be fine. And it's great. People participate. And then after that, you create a body that is taking care of the health of the city, decreasing the vulnerability of the city and increasing resiliency. And they get like wonderful ideas. Like, let me give you one. In a port city that I was helping, they only have one road to come to get in and out, like all Boston. Remember, it used to be a peninsula, and there was only one way in and out. Okay. Somebody thought that one of the best ways to actually create a secondary road was to, in case it was needed, a lot of the boats that they have in the city of a certain type will line up and they will put pontoons on that, and it will be a temporary bridge just for the city. And they thought about it almost immediately. So my point with this is that it generates that mindset for innovation. And people know that, well, even if we get it, we will be ready for that. Okay, so they are not afraid of the weather or extreme weather events. They know that they are ready for that. The only thing is that they don't know what's coming. That's the uncertainty. But they are not afraid of it because they know what to do in case that happens. And what are the most important challenges? Do you think it's money? Do you think it's willingness? What do you think will be the most challenging thing to implement something like this? Say it again. Prioritizing, that's one. Or saying, should we do it at all? You know, yes? Long-term thinking. Most politicians, they think in 4-year terms, in 8-year terms or something, that's all. However, most city managers, they are thinking about decades. So let's go to the city managers in order to implement something like this. Anything else? Maybe changing policies, you're right. There may be some policies within the city that preclude some people from participating in that, people that are not in government. If you are not, I don't know, certified in order to participate, certified vulnerability assessor or something like that, you can't participate. No, it has to be the whole community. Anything else? Yep, I agree. So let me tell you what is the cool thing. We are recording this, okay? This is like a sales pitch for a lot of cities. If you show it to a lot of city managers and they are interested, we can create a joint program between BU and Harvard to have this educational program, and we could do it online if we wanted to. And it doesn't cost that much. It doesn't cost that much, and we could do a mass education effort so people can be resilient and they can reduce vulnerabilities in their communities, and that's what we are looking for right here. Okay, and I think that that's all. Questions, comments about this? Yes.
Different communities also come together. I mean, it's fine that we have these meetings, we have the kumbaya, I should say, with other communities, but putting it into practice, that's a different story, because if I live in one community and I wanna leave your house, you know, it seems like the buck is gonna get passed around. How can you prevent that?
Well, one of the
That happens everywhere, you know that.
yes, but one of the ways is to actually, there is a movement that is called 100 Resilient Communities or 100 Resilient Cities, and they share the lessons learned on how to deal with these issues all the time and how to avoid people from passing or kicking the can or passing the bucket or not participating. Like there is a whole chapter on how to chain elected officials into actually working on this and how to do the inception to tell them that it was their idea to actually do it and to get most of the credit and the community benefits at the end. Like for real, I'm not kidding. I think that you have to get into that and then you'll see how there are several things, several mechanisms. But as I said before, this is just one way to assess vulnerability and to increase resiliency. It happens to be very easy to implement and very easy to massify. That's why I use this one. Okay? But yeah, there are ways to get rid of that because the problem is precisely political will is the most scarce resource we have right now. And that's why we have to use other arguments, persuasion arguments, in order to make sure that there is some action about this. Okay? Any other questions, comments?
What you said just now, Dr. Sanchez, is exactly the same. The first line of this class is talking about. So it's exactly that, this is exactly what it's saying.
Thank you. Anybody else? No, I think that, yeah, go ahead, please.
Thank you, Ramon, for the lecture. In your experience, what's the best way to convene and engage communities and train them and keep them excited to participate? Because I agree with you, that's the best way to get the best knowledge to make a proper risk assessment. Because in our experience, in our industry, sometimes we didn't assess the risk correctly. So we didn't put the corrective action, and then we had the problem.
Mm-hmm.
So you need a lot of inputs from experts, but also from the community. So how to grab all that knowledge, put it together, and make that a proper risk assessment. I think that's what
Okay, so I'm going to tell you my method. You'll decide if you use it or not. Most of the time, I go to city planners or city managers or the mayors telling them that I have some cost reduction opportunities, okay? And they will be thrilled. Like, what do you mean cost reduction? Yeah, we are going to reduce electricity consumption, water, and waste, and the whole thing. And they are like, and that's a proven solution. We have done it several times and everything. And they are like thrilled. However, in order to do that, you will have to sponsor the community. The 300 people that are going to learn this, you have to help me to rally them into accepting this educational program, and you have to support them, because if not, you are not getting any savings. And then what will happen is that the government will support this, so people will be trained for free. And once they participate in this, let's say that BU and Harvard were giving a very small certificate of participation in the program. For that piece of paper, they will do wonders. They will do the climate change preparedness plan of the city for free and the whole thing. Then after that, you have to create an NGO to keep it going every single year, okay? And then at the end, it will be an integral part of the community, and it will keep going all the time. It may get funding or grants from the government itself or from other organizations like the Inter-American Development Bank, the North American Development Bank, the World Bank, and other places, just to keep that organization going, because they know that because of that, you will be resilient and less vulnerable to climate change all the time. And that's why I will be supporting your organization. And as long as you don't make it a political organization, it will be impervious to the political ups and downs from different parties, and you'll be fine. And if you keep membership really high, then that will happen because people from one party will be in power one year and people from another party will be in power the other year. But all of them belong to the organization. Okay? Good. Yeah.
With Trump in office, it feels like now I'm starting to square one again. You know, with the tariffs, he wants to get us out of the cars agreement and climate change, and I feel very discouraged, and I feel like I'm starting down at one again. You know, so what do you say to people that feel that way too?
First, don't be so concerned because we have the solutions. We just have to change the language that we use in order to address these things, okay? So let's say that I was in another state, one that I show here that had like a huge drought in that western part of that state where they don't believe in climate change, okay? I would not call it a climate change preparedness plan. I will call it an independence and reliability plan for the community. I will use the most patriotic name I could do, and I will do exactly the same thing that I'm doing, but I would do it for energy independence to make sure that nobody will be able to dictate what kind of energy we use, to make sure that you will be as independent from the government as you can, and the whole thing. So the language changes, however, the tools are the same. At the end, they end up doing exactly the same things. And the difference is how you use the language. If you tell them, I'm doing it because of the seals and the polar bears, no way. People in Western Texas will not care about that. However, if you tell them that it's in order to be energy independent, to reduce electricity bills, to save water so you could use it for what you want. Like for example, they don't let you water your lawn because there is no water. So I'm fighting to keep those leaks out of the system so you could water your lawn. I know that that is not like the optimal thing to do. However, if you are saving from the leaks, you are wasting 40% of the water. And just by watering the lawns, the lawns, then you only use like 5% of that water that you avoided, from being wasted. You're fine. It's only how do you change the language. It's almost like convince them that you are doing it for the money, not for the environment. At the end, they are so highly correlated that it doesn't matter what you do because you will be doing it for both things. However, some people care about the money and some people care about the environment.
And that's one of the reasons why this precisely the right time to do is because every year environmental issues and monetary concerns become more tightly coupled.
Mm-hmm.
And so I think you're exactly right. You don't even have to talk about the environment. It's almost all the same now because so much of what's driving at least public and private costs are environmentally derived now. So you can use one set of paradigms and language in one community. In Cambridge, you can talk about seals and polar bears.
Yeah.
In Texas, you don't, but who cares?
That's right.
If we're solving the same problem, who cares?
That's right, but you are solving the same problems and you are using probably the same technologies. Don't you think that people in Western Texas will love to have their buildings with air conditioning without using electricity and it will be free? They will love it. The only thing is that we have to tell them that we are doing it for the money and then they will adopt it. Sooner or later, they will realize that it has environmental benefits and they would say, by the way, I'm a green cowboy now. Who cares? That's fine as long as they do it.
And also saving money is also a good thing.
I know it's good for the economy because then we can use it for something else. But my point is, let's change the conversation because at the end we can do the same things, but changing the conversation may help. Yes. Kind of promising, and as you say, what if we say like, in order to prevent this land, we are losing. My guess is that you are losing the sandbanks. Am I right? And also at the rivers. What are we losing in Louisiana right now? Eroding. Okay. Well, in order to let's say that we have a new land strengthening system. Let's call it that. Okay, it doesn't exist, but we call it that. And in reality, we are reforesting. We are making sure that there are roots right there in the whole thing. And we tell them that that is a land reformation system. They will love it. But we have to call it that. We cannot call it the climate change action plan because immediately there will be like a big conflict right there. So my point right now to environmentalists for the next 4 years is be flexible. We are on the right side of history. We just have to call it something else. It's just not that we are giving up ground. It's just that we need to make sure that we have some advancement in these 4 years. And I agree with you. That's really encouraging. Now, my concern is that it may not be enough because let's say that the governor of Louisiana is doing that, but not the governor of Mississippi, not the governor in Georgia, and they keep using coal-fired power plants. Engage people into doing something, when in reality I should say, let's clean air, let's clean water. But by saying protecting God's creation, I got them immediately and they are doing exactly what they are supposed to be doing, except that I'm using a different language. Not being cynical here. It's just using the tools at your disposal. That's right. Good. Well, thank you so much. Thank you. Thank you. And I guess that you are going to receive both the tables and the presentation soon. And so thank you so much. Thank you.